Hello everyone. So in this lecture we will be studying that how to apply DP optimization onto our recursive algorithm which we have studied earlier. So the min coins problem is actually making use of the same kind of algorithm which we have studied in the number of ways to make a change, but we need to find out that what are the minimum number of coins to make a change, not the number of ways to make a change. So if we want to have a quick refresher, then what were we actually doing over here? So what does this subproblem say? This subproblem says that currently I am sitting at index 0. So starting from this index till end of the array, what are the minimum number of coins needed to make a change of 3? But I would be adding 1 over here because this one says, okay, whatever might be the answer to this subproblem, but at least I have made a use of 1 coin, and that was 1 over here because this is the branch in which I am making use of a coin. Whereas in this subproblem, when I am excluding the denomination, what does this subproblem say? This subproblem says, okay, that I have dealt with the denomination present at this index 0. Just tell me, starting from this index 1 till end of the array, what are the minimum number of coins needed to make an amount of 4? So this subproblem said that. So whatever will be the answer I would be getting for this subproblem and this subproblem, I would be taking min of it, and that minimum would be the answer to my intended problem. So this was the recursive algorithm which we actually applied in the previous lecture. So before going on to the DP optimization, I just want to say that it would be highly beneficial for you if you just create a recursive tree by starting with the last index. So instead of starting with the 0th index, it's better if you go over here and start with the second index. So you can then make the distinction that how do we actually make use of the same algorithm, but once we are making a recursive tree from starting index, whereas in other case we are making the recursive tree by starting with the last index. So if you want to make it, you can just pause the video, give it a try, and then come back to this DP solution over here, because in the case of DP solution we will be making use of the recursive algorithm where we start with the last index. So coming on to the DP algorithm, what do we have over here? We have our columns and we have our rows. This is the same DP table which we were actually making use of in the num ways to make a change. This again says that the intended amount which we need to make. So suppose this is the amount if we need to make 3. So this is the amount if we need to make 2. This is the intended amount which we need to make. This because these are the amounts which we are actually recursing for. We are recursing for amount 3, then we are recursing for amount 2. We are also recursing for amount 1. So these are the subsequent, or these are the intermediate amounts which we were actually recursing for in the case of recursive tree. The same way we would be making use of these with the help of columns in our DP matrix. Now what does these rows specify? These rows specify the denominations which we have currently. This is the same array which we have written over here. So what does the 0 signify? This 0 signifies that the total amount which I need to make now is 0. So if you want to make 0 amount, so what does it actually mean? That actually means that from the starting problem which we were intended to make, from that point to the current leaf node or the current base case, we have already achieved the amount which we intended to make. So if we see over here in recursive tree, we have a 0 amount over here. And how do we have 0 over here? Because look, how did we start? What was the intended amount which we need to make? It was 4. Then I made a use of 1 and I was left with 3. Then again I made a use of 1, I was left with 2. Then again made use of 1, I am left with 1. Then again I made the use of 1 and I am left with 0. So what does this path say? This path says that I made use of 4 coins of 1 and then only I would have reached this 0. So when I have already reached 0, so there is no need to recurse further, and hence this was my base case. And what does this subproblem say? This subproblem actually says that I am sitting at 0th index. From this index till end of the array, just tell me what are the minimum coins needed to make amount of 0. So when the amount itself is 0, do you even need a single coin for it? No. And therefore we were returning 0 over here. This 0 specifies this thing, and this 0 over here specifies that the total amount which I need to make currently is 0. So how many ever coins you have, but if the amount itself which you need to make is 0, so you just need to have 0 coins, and hence I would be populating 0 over here. I hope you would have understood why I'll be populating 0 over here, because this is my base case. This is my leaf node over here. So what does this first row specify? This first row specifies that I am not even left with a single denomination with me, but I still need to make an amount. So what does this intersection of 1 and this 0 means? This intersection of 1 and this 0 means that I am still left with an amount of 1 to make, but I am not left even with a single denomination now. What does this 2 and this 0 mean? This 2 means that I am still left with an amount 2 to make, but I do not have even a single denomination left with me. So I am talking about this leaf node, this min coin 1, 3. Look, what did this 3 specify? This 3 specified that I am out of bound in my denominations array. So I do not have even a single denomination left with me, but I am still left with some amount to be made. This is what over here, I am left with an amount 1 to be made, but I do not have even a single denomination with me. So what we were doing in that case, we were returning int max. So that's what we would be populating over here. What we would be populating, int max in all the cases. M over here actually specify int max -1, and I hope you would remember that why are we making use of -1 over here, because we discussed it in the previous lecture. So we are done with our base cases and we are done with our leaf nodes. So if we want to see that how would we actually implement it in the code, so what are we doing over here? What am I saying? That for my 0th column and for each row, my 0th row, 0th column, first row, 0th column, second row, 0th column, third row, 0th column, what are the values I am populating it with? I am populating it with 0, and I hope you would have understood why are we populating it with 0. In the other base case, what am I doing? I am putting my 0th row, first column, 0th row, second column, and so on with int max -1. That's what we have discussed right now. Why are we populating it with int max? So now coming on to the other cases, because we have filled our base cases, if we want to see what do we have in our base cases, we can have a look over here. Yes, this is our DP matrix. So we have filled our first row and first column. Please ignore these. We will be discussing that how have we actually populated all this. So we have filled our base cases. We know our first column contains 0 and our first row except the 0, 0 contains int max -1. So how do we populate the other cases? What do we see over here? What does this intersection and this intersection mean? This means that we are left with an amount of 1 and we have a denomination of currently 1 with us. So this means this thing, that I only have a denomination of 1 with me and I need to make an amount of 1. So what do I do over here? If I need to either include the element or I need to either exclude the denomination. So if I include the denomination, then what would I be doing? I would be subtracting the value of the denomination from the intended amount. So what would I be subtracting from intended amount? The current denomination. So what is my intended amount? That's 1. What is my current denomination? That's 1. So what would I be left with? I would be left with an amount of 0. And then I would be saying, okay, just tell me with the current denomination again, starting from the 0th index till this denomination, what are the minimum number of ways or minimum number of change which can be made use of to make an amount of 0 over here? And I would be adding 1 to it. Look, what did we do in the recursive tree? What did we say? That okay, I made use of the denomination present at this index. I subtracted it from the denomination, from the amount which I need to make. So I am left with now 3. But I didn't change the index over here, because if I would have changed the index, then in no way I would have reached 4 ones over here. This path, what does this path signify? This path signifies that I made use of 4 ones. So when I include the element, I do not change the index. I just make use of the denomination and subtract it from the intended amount. And then I add 1 to it. I add 1 to it because whatever might be the answer to this problem, but at least I have made use of a single coin, and that's the denomination which is present over here. So that's what I have done over here. And what if I exclude the current denomination? So if I exclude the current denomination, so what would I be left with? I would be sending in the total amount, but to the leftover or the remaining denominations. So what are the remaining denominations? They are 0 because I currently only have 1 denomination with me. So if I do not make use of this denomination, so what am I left with? I am left with the amount of 1 with the remaining denominations. So where can I find this subproblem? What does this say? That I have an amount of 1 to be made, but I have no denominations left with me. So it's infinite max over here. Sorry, int max over here. So if I exclude the item, so I have an answer of int max. So where can I find this subproblem where there is no amount to be made, but I have a denomination of 1 with me? So can I say it's this subproblem, the intersection of these two? So answer is this one. So the answer to this subproblem is 0. So the answer when I include the current denomination, it's 1. So what is the minimum of 1 and infinite? Again, I will be taking the minimum of these both. It's 1 over here. So what is the answer which I will be getting? It's 1. And what does this 1 signify? This 1 signifies that if I have an amount 1 to be made and I have a denomination of 1, so the minimum number of coins with which I can make this amount is actually 1. So what does this mean? This means that the amount which the amount which needs to be made is 2 and I have a denomination of 1. So I have an amount of 2 to be made, but I have a denomination of 1. So if I choose to include it, then what would I be doing? What would I be recursing for? I would be recursing for the amount of 1. And I would be adding again 1 to it because I chose the denomination. So, and what about if I exclude it? So what is the amount which currently I have? 2, because I chose to exclude the element. So I would be making use of the denomination and I would be recursing for the remaining elements. What does this subproblem say? This subproblem says that the amount that is to be made is 2 and the denominations which I am left with is none, because I only have a single denomination over here. Till now I have only a single denomination. So if I need to recurse for the remaining denominations for this amount too, so actually it's an empty array or empty denominations array. So where can I find this subproblem 0, 2? It's over here. The answer to that is infinite. Where can I find this subproblem 1, 1? It's over here. 1, 1. The answer to that is 1. So what is the answer to 1 plus 1? It's 2. The minimum of 2 and infinite is 2. So the answer to this subproblem is 2. What does this 2 signify? This 2 signifies that if I need to make an amount of 2 and I have the denomination of only 1 with me, so the minimum number of coins which I need to make this amount is 2 over here. The same way I will be populating all the DP matrix contents over here. But before going on to the code, I just want to discuss two things with you. Now, do you see that what is the amount which needs to be made? 1. What is the amount? Okay, the denomination currently I have, it's 1. So do I need to even branch out to check what are the minimum number of coins? No, because if I only have a coin of 1 and the intended amount itself is also 1, so I can make it with only a single coin of 1, and hence I can directly write the answer of 1. I need not include and exclude. I need not branch out for this thing. Now suppose if I am talking about this matrix cell, the intersection of this 2 and this 2, what is the amount which needs to be made? 2. And what are the denominations which currently I have? I have 2 denominations. So what are the minimum number of coins which are needed to make this amount? The minimum number of coins are again 1 only, because what is the amount to be made? It's 2. And what is the denomination I have currently in my hand? It's a denomination of 2 again. So I can just make use of this 2 and I can have total amount with me. And hence whenever you see over here, when the amount to be made is equal to the denomination which currently I have, when they both are same, so I will directly write a 1 to it. I won't be branching out. I won't be including or excluding over there. This is the first point which I want to talk about. The second point is, now suppose the amount which is to be made is 1, but the denomination which you currently have is 2. So do you even need to branch out again? No. Why you need not branch out is, we can see it over here. Look, what is the amount over here? The amount over here which needs to be made is -1. And how did I get -1 over here? With the help of this thing. What is this min coin 1, 1? This says that currently I am sitting at index 1. Just tell me, if starting from this index till end of the array, what are the minimum number of coins which are needed to make an amount of 1? This subproblem says this thing. So if I choose the denomination present at this index, what is the denomination present at this index? It's 2. So if I choose to make use of this denomination, so what is the amount I would be left with? I would be left with an amount of -1. So what would be the answer to this leaf node? The answer to this leaf node is int max. So whatever might be the answer to this thing, the answer to min coin 1 will always be dependent on this when I exclude the current denomination. Why? Because I am taking min of these both. So whatever might be the answer to this thing, it would be always smaller to this int max over here. Again, why is the answer to main coin 11 only dependent on the branch when I exclude the current denomination? Because if I include it, then the answer to that subproblem would be int max. So whatever might be the answer to my this subproblem when I exclude the current denomination, the answer to my whole subproblem would be dependent only on that thing, because the minimum of int max and anything other than that would always be the other thing, because there can be nothing an integer can hold which is more than int max over here, and hence I would be just recursing for this thing. So if we see over here, what is the current amount which needs to be made? It's 1, and currently I have a denomination of 2 with me. So if I include it, so what would I be recursing for? I would be recursing for 2 comma minus 1. What does this minus 1 say? This minus 1 says that the amount which is to be made is minus 1. So do I have anything of such kind in my matrix? No, and hence I will not include it in these cases. The answer to these kind of subproblems where the denomination which I have in my hand is more than the amount which needs to be made will only be dependent on excluding that denomination. So I would be excluding that denomination, and what would I be doing? I would be saying, okay, the answer to 1 1 will be same as the answer to 2 comma 1, and hence I would be putting the value of 1 1, which is 1, over here. I hope you would have understood why is my answer in such cases where the denomination is more than the intended amount is only dependent on excluding the item over here. So if we come to the code, what can we see over here? Look, if the amount which is to be made is less than the denomination which I am having, so what would be the answer? I would be recursing for the same amount with the remaining denominations I have. So that would be the answer to my current subproblem. If the amount which I have is equal to the denomination, such as in this case, this one, this 2, this 2. So in this case, if it says that the amount which I have is equal to the current denomination which I am having, so what are the minimum number of coins needed to make that amount? It's 1, because the amount which is to be made can be made with the help of the same denomination which currently I have. So I need not go further over there. So the answer to that subproblem would be 1 directly. Otherwise, what would I be doing? Then I would be branching out and taking min of those things. What does this subproblem say? This subproblem says exclude the current item and recurse for the remaining items with the same amount. And what does this subproblem say over here? This subproblem says include the item and just recurse for the remaining amount. Look, I have deducted the current denomination from my current amount, so I would be left with remaining amount, and I would be adding 1 to it, and then the min of this would be the answer to my current subproblem. I hope you would have understood this. If you didn't understand, please rewind the video and check it once more. So this is the DP matrix which we have filled over here. What does this 2 signify? This 4 and this 3 I am talking about, the intersection of this 3 and this 4. What does this mean? This is the intended problem which we're actually trying to make. What does this say? The amount to be made is 4, and currently I have 3 denominations with me. This is this subproblem. So can you see, this is the subproblem which we are recursing for over here, and this is the original subproblem. So the answer to this subproblem is 2. What does this 2 signify? This 2 signifies that the minimum number of coins with which we can make 4 with the given denominations is 2. This 2 specifies this thing. So I hope you would have understood how are we populating our DP matrix and what are the base cases and what are the leaf nodes over here. So in the next lecture, we will be looking at another DP problem. Till then, thank you.